Welcome to Chapter 6, Foundations of Business Intelligence, Database and Information Management. So what are our learning objectives today? We're going to be looking at what problems managing data resources have, some DBMS, why does it work and what is it, the principal tools of technology assessing information from databases to improve business decision making, and why are information policies, data administrations, and data quality assurance essential? This is basically about databases and how they all work and why they are so important to businesses. Basically, a database consists of a file. It's a group of related files. The files are a group of the same type. We have a record. We have fields, entities, and attributes. So basically, our attribute, it's each character that puts it together. And the entity is the next level up, which is the person, place, or thing. And the field, think of it as Excel going across as a row. And the entities are the groups. When we have a whole bunch of these, we have our file. That's basically how a database is built. So what do we have some issues with? Some problems with traditional files in our systems. Files maintained separately by different departments, which means HR has a employee list of how everyone is, where they live, what they get paid, and all that. Your department might have a separate list. It could have different information. So if I change my address, I tell my department, he might not tell HR. So there's different information. So that's a problem. Data redundancy, as I just said, there's two pieces of information that might not be updated. Inconsistency, it's the same exact thing. I updated one, I didn't update the other. So these are some of the things that we have to look at. Poor security. HR might have awesome security on their systems. My department manager might leave it on his desk. And lack of sharing information available. These are some of the basic issues that we've had over the years that the database has kind of solved. So the database consists of, serves as an application by centralizing data, putting it all in one central location. Different departments can access it. And usually there's a database administrator, and he or she goes in through the database management systems, the DBMS. And basically what this DBMS is just an interface of information to the actual data. Usually users do not have access to the data. Usually users only see it through an interface that was built by the database administrator. They have a screen that they can go on, enter information, and run reports. That's basically all the user. But the DBMS has access to down to the information level. So if I wanted to change a date, I'd have to go through a database administrator to actually go in and change something. Very rarely does users have access to change information. So this is an important part, and that DBMS allows us to have that information. Now we have a relational DBMS, which represents two-dimensional tables. Think of it as two Excel sheets. If you think of Excel, you have one worksheet, it has information on it. Well, that second worksheet you have, they can't talk to each other. That was the old filing systems we've had. Now relational allows us to have information that talks to each other. Think of that as linking those two tables together through a certain key field or a primary key or foreign key, something on that order that uses that database. And now that database, if you think of it, is now it's two-dimensional, where it can go across all the different sheet tabs across your Excel spreadsheet that your Excel can't do and a regular database can't do. But relational allows us to have this information. And again, it looks just like Excel, columns and rows. Some of the basic commands that we have with a relational database: we can select subsets, we can join them and combine them, and we can have projects that create the subsets for us. So there's a lot of commands within the database that we can do that normally that takes care of it. So within the database, when we're creating one, we have to have something called the database management system. Which is defined, when you're going to create a database. Databases aren't like Excel, we can just add information. Databases are extremely structured, and we need to think about them more up front than we do with a basic Excel spreadsheet. So when we have to create it, because they're not as flexible. Once you build that database, and the problem comes into when we start putting data in. Think about it. If you had a database, you had a million rows of information, and all of a sudden you want to make a change to it, well, how are you going to change that history? And this gets us back to the Y2K catastrophe that happened on New Year's Eve on 1999 when we turned to 2000. That whole century area created a major issue, caused millions of dollars to correct it. And that's because someone didn't think about the actual what was going to happen when we turned to the year 2000. So the structure of a database is extremely important. And within that structure, we have something called data definition. This is going to describe what our database is. We have a data dictionary that has the words and tells us what every column is, what it's going to be. And we're going to run some reports, querying and report. And you might have heard of SQL, which is structured query language. That is the basic language to get into databases. It is used just about on every database and allows someone to talk to it through programming. Allows that to have information. One of the most common is Microsoft Access. It usually comes with Microsoft Office, so you have that. So a couple of things when designing that database, we have to have normalization or streamlining the complex areas that allow us to have it. If we have too many links or anything, it gets confusing. So we really have to think about what we're going to be doing it. And to do that, we use a tool called entity relationships diagrams. And this allows us to visualize what's going to happen before we actually put it together. As I said, once a database starts collecting data, it gets really complicated to figure out how we're going to fix it. So the design is very important. Non-relational databases and databases in the cloud. Non-SQL are more flexible, they're easier to scale, and then we have the databases in the cloud, and that's just someone else running it for us. So we don't have to worry about it. We don't have to buy hardware that's specific for a database. We can go through some of these cloud services, and if you're a small business, this is ideal for you because now you don't have to worry about the database administration part, because on the back end of a database, there's a lot that goes on that people don't think about. And someone just builds a database. If they don't maintain it, it runs into problems. So database in the cloud takes care of all of our back-end issues, making sure it's always up and running and that it's always going to be there for us. So what does all this lead to? Big data. With the explosion of the internet, there's more data collected today than we have in the entire history of the human thing in the last 5 years, pretty much. Everything is now on the internet. You go on the internet every time you go there. So what do we do with all this data? So there's massive amounts of structured and unstructured data. As we talked about, structured data is something that we have. Name, addresses. Unstructured data is just text, if you want, pictures that don't mean anything, and semi-structures are right there in the middle. But right now, there's just too much information. There's petabytes and exabytes of data. So how do we find what's going on in these? How do we figure out where that nugget of information is? If I'm running a business, I want to know what all my data collects. If the government is collecting all this information also, what are they doing? So there's been a whole bunch of tools that have come up that obtain some information. So one of them is a data warehouse. And basically what it does is it takes the database, puts it offline so we can actually start running data on it. We can start looking at it. Store current historical files, it consolidates information, provides analysis tools and reporting tools that we can look at. We can also look at in-memory computing used in big data analysis. It uses the RAM on your computer. It reduces hours into a few seconds of using that, but it's a high performance that allows us to collect information. Some other tools that we're going to look at is multiple dimensional data analysis, or Olap, data mining, text mining, and web mining. Because really, having all this data is awesome, but we've got to get that information out of it. Otherwise, it's really a waste to collect the data. So Olap is online analytical processing, supports multi-dimensional data analysis, viewing data using multiple dimensions, each aspect of the information, product, cost, pricing, region, And this allows us to look at the data differently than what we have. Usually we can run some reports, ad hoc queries, and it allows us just to gather information out of this data. So I don't have to sit there and look at all the data. I can get very specific on what's going on. Data mining is something that a lot of companies are starting to look at. It finds those hidden patterns. What are we looking at? What is a customer buying, when, why, and how? And by knowing this information, we can better target them so they can buy more product from us. Types of association, sequential, classification, clustering, forecasting. These are just some of the methods that are used to help us with the data mining. Text mining and web mining extract key elements from large unstructured data. So discovery analysis, web content mining, web structure, these are just some of the things that we're allowed to have it. Database in the web. As we get more information on the web, as the users become more web savvy, which everyone has been, they put more information in the web, hence why Facebook is so big. But this allows us to collect information on them. And then we take that information and we figure out what's going on with it. So what kind of policy does all this mean? And we kind of looked a little bit into this on our policies and procedures. But what are roles for sharing that data? What is Facebook's policy for letting third parties have that data? As you said, as we've seen in the past, they've been in a lot of trouble. Data administration. Who's allowed to see it? Who manages it? Data governance. Dealing with the policies for managing usability, integrity, security of that data. We hear about data breaches all the time. What are they doing about it? And last thing, data quality. Here's the thing. We can have the best data in the world, but if it's not good data or quality data, it means nothing. Because basically what's going to happen, we're going to make the wrong decision based on our data. So we've got to make sure that the data within there is correct. There's no faulty information. Because they said management makes decisions on this. And if it's not right, they're going to make the wrong decision. So we have audit teams that go in. We do data cleansing that allows us to have information on it. So the whole system comes to, we collect information from something called the TPS, which we talked about a couple of weeks ago, which is a transactional processing. It all goes into the database. Database, we get a large amount of data from it. We run reports for different departments, decision-making supports. Management requests this information. We look through our data. We try to find our trends, and we figure out what's going on. So that's what our database is about. And it's about big data and how this all comes together. So that was our lecture for this week. So remember, get out and smile.